and welcome to this tutorial in which we're going to try and simulate the normal distribution using the Python programming language. We're going to be approaching this by two different methods. The first one is going to be using the idea of a binomial distribution and how a binomial distribution can start to resemble a normal distribution and can be approximated as a normal distribution when n is large enough. And the second one is going to be simply using a function from the Numpy package that will take in a couple of parameters and will give you your desired normal distribution. So, quick reminder going off on the first one, first method, the binomial distribution is essentially a distribution with n number of repeated trials that are completely independent of one another and have two possible outcomes, success and a failure, with p being the probability of success at every trial. So think of, say, a coin toss with the probability of heads or tail being equal to 0.5. And what we want to leverage over here is this idea of central limit theorem, which states that if n is large enough, any binomial distribution is going to converge into being a normal distribution. Okay, so how do we simulate that in Python? So the first thing that I want you to do is to import these packages. The first package we're going to import is SciPy, and you can get some more information if you are curious about SciPy at docs.scipy.org. From SciPy, we are going to be calling in the module stats, and from stats, we're going to be calling in a function binomial. For visualization, we're going to be using the popular visualization library called matplotlib. If you want more information on matplotlib, you can go to matplotlib.org and see all of the cool modules and functions they offer there. And we're going to be calling matplotlib because it's a pretty big name, and pyplot, it's a pretty big name, so we're just going to call that as plt. So let's run this cell, and next let's define some variables. So the variables that we are interested in are, first, we are going to be defining the range of values at which the probability of success is being calculated. So over here we are looking at I, which is going from 0 to 10. Next we are establishing the value of n and p, n over here referring to the number of Bernoulli attempts. The Bernoulli attempts are the attempts that are creating this binomial distribution, and p, which is referring to the probability of success that we mentioned here. And the third variable, rv, is essentially calling the binomial function we imported over here that takes in the parameters of n and p. So we call that cell, and now we try to visualize it. For this visualization, let me explain to you how it looks like, and then maybe explain the code to you. So if you run this, this is the kind of graph you're going to get. Over here, what we're doing is that matplotlib.pyplot is calling in the function vlines. Vlines is essentially referring to vertical lines. So these are the vertical lines that it is calling, and this is going to be used in order to represent the distribution we want. I over here refers to the x-axis, and 0 over here refers to the minimum of the y-axis, and rv.pmf at every I. PMF is the probability mass function at every I. So this determines the maximum value for each of these vertical lines that we are drawing over here. A number of other arguments that you can pass in, like color. I chose the color red. You can choose the kind of line that you want, the style of the line that you want. I chose a dash over here, and also the width, which I am calling as 1.5, and the label, which you can see over here. Finally, you just add in the legend and you call in the show. function for matplotlib. If you don't want this box around here, all you have to do is simply write frame on equals false, and you run it again, and you're going to see that the box also goes away. But what about that idea of n being large enough, right? So this doesn't exactly look like a normal distribution that you might see, say, for example, over here. Oh, sorry. Oh no, this is the binomial distribution. Anyways, what we want to do is kind of see the smooth kind of distribution, and what we see over here is resembling what we are seeing over here, which is discrete values. So no smoothness to the curve. So in order to create that smoothness, what we can do is we can change the value of I, and we can make that go to 1,000, say. N is large enough. 1,000, I think, is large enough. And we can also make the number of Bernoulli attempts go up to 1,000 as well. So if you run that cell and then you run this code again, you're going to see something that resembles much more this curve that I'm showing over here. So that's the first way of getting this done. The second and more easy way of simulating a normal distribution would be simply to import the Numpy function. We imported it over here. You define a variable called counts or whatever you want to call, and you call in the module random, and call in a function normal, which essentially is saying that you have to draw random numbers from a Gaussian or a normal distribution. And over here, in the first argument, you pass in, say, 100. 100 is the mu. It's the mean that you want the normal distribution to have. You can have 3 as the standard deviation. And this number, the third argument, is essentially going to be the number of random numbers you want. Finally, you're going to just plot the histogram, plt.hist. That is the histogram of this this variable that you've calculated, and you're going to say you're going to tell matplotlib to show it to you, and it looks something like this. If you want it to be a little bit smoother, you can see that the histograms usually have a default value. They have a fixed width, not fixed width, but like a default width. If you want to change that, you could, and make it look more like a normal distribution, you could just go into, say, bins equal 100 over here, for example. A bin is referring to one bar of this histogram, and you just run that and you equal that to 100, and you're going to see that it starts looking more smoother and more like a normal distribution. So hope that helped you, and if you are interested in more videos related to Python and social science and how to conduct inferential statistics or descriptive statistics using Python programming language, feel free to like, comment, share, and I'll post some more videos. Take care. Bye-bye.